my answers from the write-up and walk you through the code I wrote to implement the Needleman, Winch, and Blast for fuzzy genomic sequence alignment. So let me start with the result and answer I provided in the write-up. This assignment involved running the fuzzy search using the two algorithm. So the first one is Needleman, Winch, um, uh, and blast algorithm. Second is blast algorithm, and each algorithm has two part, one using real subject data and one using random input sequence. So for problem 1a, I used 10k, 100k, and 1 million and 32 mers extracted from the human genome file. I compared them against the query dataset using full Needleman Winch alignment. Winch alignment. The number of hits I found, meaning matches with two or fewer matches, were around 1,274 for 10k over 13,000 for 100k and 1,26,000 for 1 million. Each alignment use a match score of +2 and penalties of -1 for mismatch and gaps. So for problem 1b, I generated random 32 merts. As expected, this produced very few hits, just 7 or 10k, just 7 for 10k and about 740 for 1 million, and took nearly the same amount of time to run. For problem 2a, um, um, this involved using blast. So instead of scoring all sequences, I first filtered by checking if the 11 character seed matched. Only if the seed matched did I run Needleman once. This optimization led to a big speed ups. For 1 million characters, I got over 90,000 hits in just 2 minutes. And so for problem 2b, which use randomly generated character, also had very few hits, only 311 for 1 million character, but it ran much faster than Needleman Wunsch because of the seed filter. Overall, Blast was 4 to 5 times faster than NW algorithm. So yeah, this is my conclusion on all this question. So now I'll walk you through the code I wrote for this assignment. I I go to the file that I have created. Okay. So here, I'll go to the main.cpp first. So let's walk through the main.cpp. So I use command line argument to I use command line argument here, and I have used the string compare function, which is I am comparing the second array, which is AV of 1 with the minus hyphen hyphen NW. If it is equals to 0, then we are executing this code. And for this, if the argument is this one, means this one equals to 0, it runs the Needleman-Wunsch algorithm. If it is minus BL, it runs blast algorithm. The second and third argument are the query file and the subject file path. Here it is. Okay. And this keeps everything modular and avoid hard-coded paths. And the queries NW class contain a 2D array. I will show you that class. Here I have added that class. This is the class. So query NW class contain a 2D array to store 1000 query fragment of 32 character each. Here it is. And the load function, this load function Read the query, skip lines that start with a greater than symbol, which are fast hiders, and slice 32 merge into the array. And in the second, we have used the score method, score function. I use a 2D matrix to implement Needleman winch, and I initialize the first row and column with the gap penalties. Then I fill the rest using max of match, insert, or delete. The final cell gives the alignment score. I check if the score is 62 or higher, which correspond to two or fewer mismatches. Then run function reads the subject file line by line. Here it is. Each line is assumed to have 80 characters, as I mentioned here. And what I did here is I strip new line and check the length before slicing it into 32 maps. Each fragment is compared against all query using score, and hits are counted and printed. The query's BL class is almost the same. So I will show you the other class. So this BL class in CPP, this B queries underscore BL CPP. So the queries BL class is almost the same, but add a seed filter before assignment here. I have added the seed filter. And it's in its run function for each 32 merge from the subject file. I check if the first 11 base match any query first 11. If so, I run NW. Otherwise, I skip it, and this reduce running by avoiding unnecessary scoring. So this is the score function for this, and I have used the run to implement that logic, the same that I have explained. So bugs and issue that I have faced, like I initially had a segmentation fault, which I always failed, faced, and when running my code on Monsoon, it always happened, and it happened because I assume every subject line was long enough to slice. So to fix this, I added a check if length is less than 32, uh, then I added continue statement. So I also stripped new line and recalculated line length before slicing. So this made sure I never access out of bounds memory. So this fixes remove the crash and stabilize the program. So the coming to the optimization to improve the performance and meet project guidelines.